Other variables control charts, Chapter 5. In this chapter, we are going to understand how to build and when to use other control charts for variables. Although the most commonly used are the X bar and S chart and the X bar R chart, there are other control charts for variables that we can use, and these will depend on the situation that we have and the quality characteristic that we are trying to evaluate. These charts are the charts for better operator understanding, chart for subgroup size, for trends, for moving average and moving range, for median and range, for individual values, chart with non-acceptance limits, and chart for exponential weighted moving average. So let's start with the charts for better operator understanding. And these charts are used because sometimes production personnel have difficulty understanding the relationship between averages, individual values, control limits, and specifications. So these charts will make their life easier. It's going to be easier to understand. It's going to be easier to build, okay? So there are two charts for better operator understanding. The placing individual values on the chart and chart for subgroup zones. The placing individual values on the chart is a technique that will plot both the individual values and the subgroup average on the same graphic. So the individual values will be represented as a small dot, while the subgroup average is represented with a large circle. And if they both have the same value, they will be located, you will have a small dot inside of a circle. Easy to understand and easy to graphic. The second type is the chart for subgroup zones. And this is a technique that will plot the subgroup zone rather than the group average. We're going to be using the same steps. You have to collect the data, you have to calculate the central line, which in this case is n times x bar sub 0. And then you have to calculate the upper and the lower control limits. This chart is mathematically equal to the X bar chart. However, it has the advantage of simpler calculation because it's only using additions and subtractions. Another type of control chart for variable is the chart for variable subgroup size. And this one is when the subgroup size will vary. When we went over the X bar and R chart and the X bar and the S chart, we will always using subgroup size constant. When we graphic the upper and the lower control limit, it was always in a straight line. This case, you will have up and downs because when this situation occurs, the control limits will vary with the subgroup size. So as the subgroup size increases, the control limits become narrower. And as the subgroup size decreases, the control limits become wider apart. We also have chart for trend, and this is to plot unnatural patterns of variation or natural patterns of variation. Same steps. You have to find the central line and the control limits. But in this case, the central line is on a slope, okay? And it's represented by the X bar equal to A plus BG. And where A is another factor that you need to calculate, and it's called the point on the vertical axis where the line intersects the vertical axis. And B is the slope of the line. Once you have the central line, which is represented on a slope, you calculate the control limits. You use a sub 2 times r if you're using the range chart, or you use the standard deviation, you use the other formula. This is a chart that you can easily see the dispersion of the data. Another type is the chart for moving average and moving range. And in some situation, a chart is used to combine a number of individual values and plot them on a control chart. So this is the type that we call the moving average and moving range. And it's very common in chemical industry, as well as for testing that are destructive, production rate low, transaction processing in batches, and for service and accounting organizations as well. Now for this type, this is when we have a sample size that is equal to 1. By the way, all of these are for individual, which is sample size equal to 1. So the moving range is equal to a difference of successive values in time. Values are not independent, they are correlated. You can't assume that they are normally distributed. You need to first check the distribution of values, and then how do you do that? You conduct a histogram to identify the shape of the distribution. And this type is not as sensitive to changes in process parameters. Same steps, you need to calculate the average of the moving ranges, which is the sum of the moving ranges divided by the number of moving ranges values. And this is data that is given. You also have to calculate the average of the values, which is the sum of the values divided by the number of data values. Then you calculate the upper and the lower control limits for the X chart. And this is, for instance, using n equal to 2. And this is the upper and lower control limits for the moving range chart. We also have the chart for median and range. And this will help you to minimize calculation. You need to collect data and then calculate the median and the range for each subgroup. Once you do that, you find the upper control limit and the lower control limit for both the median and the range. Now, the principal benefits of the median chart are that there is less arithmetic and is easier to understand, and it can be easily maintained by operator. We also have the chart for individual values. And this is when you have only one measurement is taken on a quality characteristic. So for here, you have to do the same. You calculate the X bar, the R bar. And with those, you calculate the upper control limit and the lower control limit for both the X and the R chart. The other type of chart, and this is a chart with non-acceptance limits, and this has the same relationship to average as the specification have to individual values. We're going to see more or understand more about this type of charts when we go over the process capability, because there I'm going to explain what is in a specification, and also what is the relationship between the specification and the control limits. But the idea here, specification is something that designers put together to make sure that in the production we always meeting or complying with the specifications. It means that this is the maximum or the lower values that the customer will accept. Okay. In quality, we also use the control limits, and we plot them in a graphic. So it could happen that these non-acceptance limits are greater than the control limits, which is the best situation because we know that there will not be out of control conditions. And this is what we call the case number 1. The case number 2, it can show that the non-acceptance limits are equal to the control limits. So there is no out of control situation, but you also don't have any buffer. And the case number 3 is the one that we're going to have problem, and it's here when the non-acceptance limits are inside the control limits. So you will find, or you can find, some non-conforming products that that are manufactured even when the process is in control. So once again, this type of understanding will come when we go over the process capability lecture. The last type of chart for variables is the chart for exponential weighted moving average. And these type of charts give the greatest weight to the most recent data and less weight to all previous data. And the advantage of this is to have the ability to detect a small shift in the process average. What it does is, like, each point in this chart contains a weighted effect from all of the previous points. So both charts are used to track process level and detect minor shift away from the target. So this lecture gives us a better understanding of the other control chart for variables that we can use based on a situation and based on the data that we have.